Insertion sort. Our task here is to complete the insert function, which is used to implement the insertion sort. Let's start with an example. We all have played with cards, right? So, how actually we arrange them in our hands? Let's take a closer look into the process, how actually we arrange the cards in our hand. Let's assume 4 is sorted here. We move to the next card, that is 2, and compare it with 4. 2 is less than 4, so we swap them. We move to next card, that is 3. 3 is less than 4, we swap them. We move to next card, that is 9, but 9 is not less than 4, so we won't swap them. Next we move to the last card, that is 7. 7 is less than 9, we'll swap them again. And boom, cards are finally sorted now. Now let's have a closer look to the algorithm. Here we have an unsorted array. Here we assume 4 is sorted. Then we move to the next number, that is 3. 3 is less than 4, so we swap them. We move to next number, that is 2. 2 is less than 3 and 4 both, so we place it to the first position. We move to the next number, that is 10. 10 is not less than 4, so we won't swap it. 12. 12 is not less than 10, so we won't swap it. Now we'll go to the next number, that is 1. 1 is less than all its previous elements, so we'll place it to the first position. Next we move to 5. 5 is less than 10 and 12, so we'll place 5 before 10. We'll go to the last number, that is 6. 6 is less than 10 and 12, so we'll place it before 10. The process works exactly the way we have sorted cards. Now let's jump into the code. Let's see insertion sort function first. We'll run a loop and inside it we'll call insert function. The I here is the particular element which we'll compare with other elements. In insert function, we'll initialize key, that is the element we want to compare. We'll compare the element with all others and place it accordingly. Now, this is it. If you face any difficulty in understanding the code, please go and check the example and algorithm again.